Hello everyone, my name is Jennifer and today I'll be showing you how to answer number 4 on the AP Calculus AB 2017 free response questions. So number 4 states that at time t is equal to 0, a boiled potato is taken from a pot on a stove and left to cool in a kitchen. The internal temperature of the potato is 91 degrees Celsius at time t is equal to 0, and the internal temperature of the potato is greater than 27 degrees Celsius for all times t is greater than 0. The internal temperature of the potato at time t minutes can be modeled by the function h that satisfies the differential equation dH over dt is equal to negative 1/4 times h minus 27, where h of t is measured in degrees Celsius and h of 0 is equal to 91. Okay, so part A of this problem asks to write an equation for the line tangent to the graph of h at t is equal to 0 and use this equation to approximate the internal temperature of the potato at time t is equal to 3. So whenever a problem asks you to find the equation for the line tangent to the graph, you always want to look for two things, the point and the slope. So in the problem, you're already given the point, h of 0 is equal to 91. So your t is equal to 0 and your h is 91. So now in order to find the slope at this point, you are going to use the equation that they gave you, dH over dt is equal to negative 1/4 times h minus 27, and you're just going to plug in 91 for your h. So dH over dt at t is equal to 0 is equal to negative 1/4 times 91 minus 27. And your answer is going to be negative 16. So now to find the equation, you could just put, now that you have your slope and the point, you could put this into point slope form, and you are going to get y minus 91 is equal to negative 16 t minus 0. So the other part of the question asks to use this equation to approximate the internal temperature of the potato at time t is equal to 3. So h of 3 is approximately 91 minus 16 times 3 minus 0. So here we just plugged in 3 into the equation that you found earlier, and your answer is going to be 43 degrees Celsius. And that is all you need to do for part A. So now part B is asking us to use the second derivative to determine whether your answer in part A is an underestimate or an underestimate of the internal temperature of the potato at time t is equal to 3. So in order to find your second derivative, we're going to have to do a bit of implicit differentiation. So we're going to take the derivative of dH over dt, which is negative 1/4 times the derivative of h, which is dH over dt, minus the derivative of 27, which is just 0. And in the problem, we are given what dH over dt is, so you can just plug that in here to get negative 1/4 times negative 1/4 times the quantity of h minus 27. And this can actually be simplified to get 1/16 times the quantity of h minus 27. So that is your second derivative. Now in the problem, you are given that for all times t is greater than 0, your h will always be greater than 27 degrees Celsius. So what that information tells you is that your second derivative is always going to be positive. So if your h were to ever be less than 27, then that would make your second derivative negative. But because it's always greater than 27, that tells you that your second derivative will always be positive. So since h is greater than 27 degrees Celsius for all times t is greater than 0, your second derivative is always positive. And that tells you that your h is concave up. Now because your h is concave up, the line tangent to the curve is an underestimate. And the tangent line gave us an underestimate. So just to explain a little bit of why it's an underestimate, let's say the graph looks something like this. So this is concave up. So whenever it is concave up, your line tangent is always going to be under the curve. Now, in a different situation, if your graph was concave down, you would see that the line tangent would always be over or on top of the line of the graph. But since we are dealing with a graph that is concave up, our estimation gives us an underestimate because the line tangent is always going to be under the line of your graph. So that's all you need to do for part B. Alright, so now we made it to the last part of the problem, which is part C. And part C states that for t is less than 10, an alternate model for the internal temperature of the potato at time t minutes is the function g that satisfies this differential equation, where g of t is measured in degrees Celsius and g of 0 is equal to 91. And it asks us to find an expression for g of t. Based on this model, what is the internal temperature of the potato at time t is equal to 3? So basically we're given the same initial condition. And now to find the first part of this problem, we are going to have to separate and integrate our dg over dt. So what we want to do is move the right side of this equation to the left side, and we want to move dt to the right side. So in order to do that, we are going to get dg over the quantity of g minus 27 to the 2/3 power is equal to negative dt. So what I'm going to do next is basically just move this quantity to the numerator by making the exponent negative. So we're going to get the quantity of g minus 27 to the negative 2/3 power times dg is equal to negative dt. So now we can integrate both sides. And to integrate the left side, we're basically going to use this rule of x to the n plus 1 over n plus 1. That's one of the integration rules. So we're going to get 3 times the quantity of g minus 27 to the 1/3 power. And when we integrate the right side, we get negative t. And we're going to add our plus c to the right side. So now the next step is to solve for c, and we are going to do this by using the initial condition of t is equal to 0 and g is equal to 91. So 3 times the quantity of 91 minus 27 to the 1/3 power is equal to c. Now here we just plugged in our t and our g into this equation. So 91 minus 27 is equal to 64. And that gives you c is equal to 12. Now we're still not done. We have to solve for g now. So here we are going to solve for G by plugging in our C into the equation we initially got. So plus 12. Now from here on out, it's basically just a lot of algebra. So we are going to divide this entire thing by 3 to get G minus 27 to the 1/3 power is equal to negative 1 over 3 times T plus 4. And we are going to cube both sides to get rid of this 1/3 power to get G minus 27 is equal to the quantity of negative 1 over 3 times T plus 4 cubed. So now we're just going to move the 27 over to the right side to get G is equal to 27 plus the quantity of negative 1/3 times T plus 4 cubed. So this is the answer to the first part of the problem. Now the second part asks us to find the internal temperature of the potato at time T is equal to 3. So now you just have to plug in 3 to this equation. So G of 3 is equal to 27 plus the quantity of negative 1/3 times 3 plus 4 cubed. And that gives you an answer of 54 degrees Celsius. So this is the answer to the second part, and this is the answer to the first part. And that's all.